Ladies and gentlemen, welcome to 4.7 Transformations of Quadratic Graphs. We're going to kick things off today with an equation of a general form of a parabola. It is also known as vertex form, where y equals the quantity x minus h, that quantity is squared, plus k. And now your numbers would go in for h and k, and there could also be a number in front of the parentheses. And so our vertex is going to be h and k. Notice how this is a positive h and k, and the axis of symmetry will be the same as your h. So let's see what these problems look like. We're asked to write an equation in vertex form and then name the vertex and the axis of symmetry for the graph. With these problems, they are a lot like completing the square of yesterday's stuff. So what I'm going to ask you to do is to complete the square, and when you complete the square, also add it to the y. So remember, the first thing we did when we completed the square, what did we have to do? We had to get the number, the lone constant, over here to the other side. Well, there is no number over here, so we're good. Now we can go ahead and add b divided by 2 squared to both sides. Well, what's my b? My b is 10 here. So I'm going to take 10 divided by 2, and I'm going to square it. Well, that's going to be 5 squared, which gives me 25. So I'm going to add 25 to this side, and remember, what you do to one side, you have to do to the other. That's a very important key. So I'm going to add 25 to the other side. So here we go. We have y plus 25 equals x squared plus 10x plus 25. Now we have to put this into two binomials. How do we factor that? It's going to be x plus 5 times x plus 5. Nothing changes from completing the square. Still bringing down y plus 25. Now, how can we rewrite x plus 5 times x plus 5? We can write that in a perfect square trinomial, so it's going to be the quantity of x plus 5, that's squared. What equals that? It's y plus 25 still equals that. Now we want to solve for y, right? Because in vertex form, y is all by itself. So I'm going to subtract over that 25. So now y equals, as I subtract over, it's going to be x plus 5. That's squared. Now I subtracted over the 25 over there to get minus 25. Now what is our vertex? Our vertex is hk, right? Well, look at this h. This is a negative h. Here, right here, is a positive. So how did I go from a negative to a positive? My vertex for the h has to be a negative 5 to make a positive here. And then my k is just added, so this is subtraction. So this is going to be minus 25 as well. Now my axis of symmetry is the same as my x-coordinate for the vertex. So my axis of symmetry is x equals negative 5. Now let's try another one. Number 2. Here we have x squared plus 3. Remember, we always want to add or subtract the constant to the other side right away. So what I have to do is subtract it over. So now I have y minus 3 equals x squared. What's our next step? Our next step is to divide b by 2 and square it. So is there a b term? I cannot find a b term, so if you cannot find a b term, what is nothing in math again? It is 0. We're going to divide it by 2. We square it, and so it's going to be 0 squared, and 0 squared is still 0. So I'm going to add 0 to both sides. Add 0 here, add 0 here, but we still have y minus 3, and that's going to equal now x squared. How can we factor this x squared, right? We're at this step here, so what can we factor? How can we factor x squared? Well, how about x plus 0 and x plus 0, right? Would that give us just a x squared? Yes, it will. So we have y minus 3 equals this. Simplifying, y minus 3 equals x plus 0 squared. Now what do we have to do with that 3? We have to add it over to the other side. So now we have y equals x plus 0 squared plus 3. Our vertex will be what's attached or what's added to the x. Well, it's 0. You can't have a negative 0, so it's just going to be 0. My y coordinate is going to be a positive 3. My axis of symmetry is just going to be x equals the same as my x coordinate from the vertex, 0. Let's try two more. Here in 3, again, we have to subtract the 15 over to the other side. So it's y minus 15 equals x squared plus 8x. What's your next step? You have to divide your b term by 2, square it, and add it to both sides. So we go 8 divided by 2. That is squared, so that's 4 squared, which is 16. So I have to add this 16 here and add this 16. Now be careful because you're adding it to that negative 15. So again, we have y, now it's plus 1, equals x squared plus 8x plus 16. Now, can I write this as a perfect square trinomial? Yes, I can. That's just going to turn into x plus 4, and that's squared. And please stop me in class tomorrow and tell me if this does not make sense to you, and I'll explain it. Please do. I'm just saving one step here. And so now I still bring down my y plus 1. We want to get y by itself, yes? So we have to subtract 1 to the other side. So it's going to be y equals now a x plus 4, that squared minus 1. What is my vertex? My vertex is going to be the opposite, right? Because I'm positive, so the opposite of this positive 4, which would be a negative 4, and keep this same 1, and it's going to be actually a negative 1. Remember, the axis of symmetry matches your x coordinate of the vertex, so my axis of symmetry is negative 4. Now in number 4, pay very close attention here, please. When you have this guy out in front, when you have a number in front of that x squared, we have to divide everything by 2. We are dividing everything by 2, and even over here to the y. So now I'm going to rewrite this as y over 2, just so I remember that I divided by 2. That's going to equal x squared plus 4x plus 5. Now after that, everything's the same. Attack it the same way. What did we do right here? We subtracted 15 over, so let's subtract the 5 over. So now it's y over 2 minus 5 equals x squared plus 4x. Now we have to divide the b term by 2 and square it, so 4 divided by 2, that is squared, so it's 2 squared. 2 squared is 4, so I'm going to add 4 to both sides. When I add 4 to both sides, I have y over 2 minus 1 equals x squared plus 4x plus 4. Now I factor this to make it a perfect square trinomial, so it's going to be x plus 2, that squared. Remember what's on the other side. It's y over 2 minus 1 equals this mess. Now we just have to get y by itself, so I add 1 to the other side. Y over 2 equals x plus 2, that's squared, plus 1 because I added it over. Now, ladies and gentlemen, right, we divided this y by 2, so we have to multiply that 2 back out. So you multiply it in front of the parentheses and to that lone number back there to get, now y is all by itself because I undid that division. Now 2 times the quantity, x plus 2, that quantity squared, plus 2. Now what is my vertex? My vertex, ladies and gentlemen, is that 2 right there. We do not pay any attention there. Is a negative 2, because it's normally minus, so it had to be a negative, and then 2 there. My axis symmetry matches my x coordinate, so it's negative 2. Now we're asked to graph some of these guys, and what's graphing look like? Well, here, if we're already given in vertex form, if it wasn't given in vertex form, you'd have to find it. First thing we have to do, name the vertex and axis of symmetry. Well, a vertex is going to be opposite of this one because it's plus, so it's negative 1 and 3 from this guy. Axis of symmetry is x equals a negative 1. So now, whenever we have our axis of symmetry, go ahead and draw in your axis of symmetry. Now we are going to graph this. We're going to graph it the same way we've been graphing the quadratic equations before. So I'm going to pick two numbers bigger than -1, which would be 0. I'm going to plug in 0 into this equation and for my x. So here we go. I go 0 plus 1, that's squared, plus 3. And I get 1 squared plus 3, which is 1 plus 3, which gives me 4. So I have coordinate point 0, 4. Next, I pick another point bigger than 0. It's going to be 1. And so I'm going to plug 1 in for that x. So I have 1 plus 1. That's going to be squared plus 3. So I come up with 2 squared plus 3. I get 4 plus 3, which gives me 7. So it's going to be 1, 7 for your coordinate point. Plot these points, 0, 4. So from your, I need my vertex, right? I can't forget about my vertex. So it's -1, 3. So I go over -1, up 3. Plot my point. Then here's another point, 0, 4. So from my origin, I stay at 0 and I go up 1, 2, 3, 4 and put a point. Then another coordinate point is 1, 7. So from my origin, I go over 1, up 1, 2, 3, 4, 5, 6, 7, put a point. Now let's reflect these points over the axis symmetry. So 1 to it, 1 away, draw a point. 2 to it, 2 away, draw a point. Now we have our points. Now we have to connect them with a U-shaped graph known as a parabola. And look at this, I'm getting better at my parabolas every single day. And this parabola represents this equation. Let's try one more. Number 6. First thing we have to figure out, what is my vertex? My vertex right here is HK. Well, now it's a -2, so my vertex just had to be a +2. My y is 3. Axis of symmetry is the same as your x-coordinate, so it's going to be 2. Go ahead and plug in or draw your axis of symmetry right at 2. There it is. And now we're going to pick two coordinates bigger than 2, so I'm going to pick 3 and go ahead and plug 3 in for your x values right there. So we have 3 minus 2, that's going to be squared, plus 3, that gives us 1 squared, plus 3, which is 1 plus 3, which gives us 4. So one coordinate point is 3, 4. Next, I'm going to pick 4 because it's 1 above 3. Plugging 4 into my x, I have 4 minus 2, that's squared, plus 3. Here we go. It's 2 squared plus 3, which is 4 plus 3, which gives me 7. So my other coordinate point is going to be 4, 7. Graph the coordinate points from your origin. 3 up 4. Put a point. 4 up 7. So from your origin, 4 up 1, 2, 3, 4, 5, 6, 7. There it is. What point did I forget to draw? My vertex. Just keeping you on your toes. It's 2, 3. And so I go over 2, up 3, right on my axis symmetry. Remember to reflect your points. 1 to it, 1 away from it. 2 to it, 2 away from it. There's my points. Connect your points with a lovely parabola. There is my parabola right there. Remember that is a U-shaped graph. This graph represents this equation. And not so fast. Just before you have a good day, let's look at number 7. Write an equation in vertex form for the parabola. Well, first, what do we need? You will need this, and it would be a good idea to make note of that. That is just the general form of a parabola. All we are adding is that little a that's going to pop up here. We will need this vertex, but the axis symmetry we don't really care about. So, looking at the graph, here's our parabola. This is just a point on our graph. That is not the vertex. Remember, your vertex is right here where your graph changes direction. So, where's our vertex at? We have 2 and 4, xy. Now, this is a vertex. This is not the xy coordinate. This is your HK, right? Because that is the vertex. So let's go ahead and use this guy to figure out an equation for it. So I'm going to plug in my HK because I already know that. So that's going to be a 2, and then I have a 4 for my K. Again, I'm getting that from my vertex. Now I'm going to use the points on the graph right here, and this is going to be my x, y points. All right, I'm going to plug that into this equation to find my a, because once I have my a, I can write an equation for this line. So my y, now just be careful where you plug it in, is 6. My x is 3. So now I'm going to fill in everything else with blue. So my equal sign, I don't know what a is, my parenthesis, minus sign, parenthesis, my square, and my plus. Now we are looking for this blue a, right? We filled in the red from your vertex, the black from the point in the line. So let's go ahead and simplify. We have 6 equals, keeping my a outside, a, and then this turns into 1 squared plus 4. Be careful here because it's 6 equals just a plain old a, because 1 squared is 1, a plus 4. We can't add that 4 into the 1. We subtract the 4 over, so now a equals 2. So once we have a equals 2, we already know what our vertex is, so we're going to plug it back in here, where we have y equals, we're writing an equation in vertex form. Y equals, our a is from here, 2, and now it just goes back to normal. X minus our h comes from here, which I'm going to put in for red. I'm going to put in red. Change it back to blue. I'm going to square that, and then again going back to our vertex plus k. You'll always use your vertex for these. For an equation, you won't use this point, and so this is your equation in vertex form of a parabola from the vertex and a point on the line. And now you can go ahead and that does it for 4.7 transformations of quadratic graphs. Good day.